Hi guys, welcome to my YouTube channel. So today guys will be doing question number 17 of our Python playlist. So guys, the first thing is you can skip this question if you are applying for a data analyst role or a citizen data scientist role, or perhaps in simple terms guys, 99% of the Indian companies won't ask you this question. So you can skip this question if you are not applying for any role which involves deep coding. But guys, this question is not asked in any of the organizations lately. But this is the question that steps basically. This is the founding stone. Okay, this is the stepping stone, and post that only you can implement anything that's high end. Okay, but if you're not clear with this also, then it would become difficult for you to implement something from scratch. But guys, the part is that 90%, 99% of the job roles don't require you to implement anything from scratch. So if you want to learn on how to implement things from scratch, you can stay in this video. Otherwise you can skip it guys, because as I said that the main objective is to make sure that you get the job and crack interviews and stuff. But essentially, if you want to join any big organizations which is leading AI innovation, then there you require this type of knowledge, and this is very elementary knowledge. Like this is perhaps if you want to have a knowledge up till 1000, this is only 100 only. Okay, not 100 even, this is 50 only. So still there would be a lot of road to cover, but we start from somewhere, right? So it's just basic linear regression from scratch. I'll be telling you how researchers actually code stuff up, and whenever you have an algorithm, how do you code that algorithm and stuff. So this question is simple guys. Okay, we need to code linear regression from scratch. Okay, so we need to code linear regression from scratch. Now see guys, the main part is you need to understand what linear regression is. Essentially, from a maths perspective and an algo perspective. Okay, rest all we can see in later on that what it is and what it is not, because that's already covered by so many people. So I don't think I can add much value there. But strictly from a mathematical and algorithmic point of view, we can stay in and deep dive into its relations and trying to understand what we are trying to do. So see guys, it's simple. Essentially in most ML based algorithms, or to start with linear regression, we have an equation that is y is equal to mx plus c. So you must have studied this sort of equation in class 11th. And then guys, the main part about it is that m is defined as the slope and c is defined as the intercept. So guys, these have implications both as at a geometrical level and at a mathematical level, but perhaps we are coding it, so we don't need to go into that form that what slope is and what it is not, because essentially guys, we would just need an function which we need to optimize. So we'll be strictly going from the coding perspective. So what happens is that you have some data and you want to fit it into this format, y is equal to mx plus c, and you wish to compute two things, m and c. Because see, x would be independent variable and y would be dependent variable. Again, let's not go into the theory. The main part of this problem statement is that you need to find out a way that you can compute m and c. Okay, m and c. So guys, what happens in this type of algorithm is that we have a cost function. So we have a loss function that is 1 by n summation y cap minus, okay, let's not write like this, it's perhaps y minus y hat whole square. And guys, I'm not seeing this from anywhere, I'm just trying to give you a glimpse of the stuff that I remember, so that it will be easy for you guys to scale it up. And I'm not seeing any algorithm anything, because I want to do it in front of you, so that you understand what essentially people at top organizations do and in what way they approach a problem. So there is a lot of maths plus there is a lot of coding involved. But in the roles in which you would be going in, you would be probably just doing coding. But see, now you have this mathematical equation. So what we need to do is we need to find the optimal values of m and c. So guys, then the main part is you need to know what gradient descent is. So gradient descent is an algorithm that helps me find m and c in simple terms. So what is the formula for m and c? So m new is basically m old minus learning rate into rate of change of loss function with respect to m old. Okay, now guys, I'll tell you how do we get this. So m new is something we're going to compute, m old is something we'll have, learning rate is something we'll fix, let's say 0.1, and rate of change of loss with respect to m old. So what is our loss function, guys? Tell me. Our loss function is 1 by n summation y minus y hat whole square. Okay, so what is y hat? Y hat is mx plus b or c. For the time being, let's just consider b. So what does this become? This becomes essentially y minus mx plus b whole square, right? Then what we need to understand, what is rate of change of loss with respect to m. So guys, first of all, you will have this derivative as 2 by n y minus mx plus b, and then a minus 1 and an x. So guys, if you don't know how to do these kind of derivatives, again as I said, you can skip it, but essentially you should know it, but it's okay if you don't know it as well. You will be able to work without derivatives as well in the organization, but as I said, if you want to go towards a role that requires a deep thinking, so you need to know all these things, and again this is the base of it. So guys, this is it, and then you need minus 2 by n, just keep bringing that minus over here, and then maybe we can just write it as x over here, and then we can have y minus y cap again. So it's essentially 2 by n summation x y minus y hat. Okay, I'm not sure whether this equation is correct or not, but let's see. As I said, I don't have anything in front of me, I'm doing it everything from the scratch. And guys, now once you have this thing, you understand how do we compute this thing, then you can compute basically m new, that is m old minus learning rate, and based on this only. So guys, see, this is how people also in organizations do. Okay, in organizations like OpenAI, in organizations like Anthropic, in Microsoft. So essentially this is what basic AI research would mean. Okay, as I said, this is just the starting point, that you have some algorithm, understand that in depth. Okay, understand the loss functions and the things which is associated with it, and then you try to code that up, then you try to improve the code and then scale it up. But that's not part of our discussion. Our part is that let's just try to understand how do we do it. And now guys, let's move towards the code part. So guys, code part is not, the code is already there. So see, I'll be telling you. So essentially, if you would remember that I got one equation. Okay, see, this is the equation that I proved you, that how do we calculate the gradient. So guys, it's not very difficult. We are just calculating and storing the MSC, and then this is the part that I just showed you. So what I was showing you in this question is that how can mathematical things be written in terms of programming way. That was the main objective. You can forget linear regression, guys. Okay, now I think no one codes linear regression from scratch. Again, 99.99% you won't require that ever. But what I was trying to show you is how can you get the mathematical optimization equation into a form of Python program. Now the thing is not very difficult if you understand linear regression. So what we are doing, guys, I'll be telling you line by line so that we don't miss anything. We are creating a class, okay, and then we are defining the init of it. Okay, this is essentially the constructor. Then I'm setting up the learning rate, I'm setting up the iterations, I'm setting up the m, I'm setting up the b. M and b is basically that y is equal to mx plus b, m and b, and then I'm just having a variable to track my mean square error. And then I have initialized parameters, these are the initial parameters, and now I want to find their optimal value, which is the task which you have been assigned in linear regression. Okay, in simple terms, now the thing is, you will start by making prediction self dot m into x plus self dot b. There was initialized 0, so this would be 0. Then you compute the MSC, and then you store it into a list, and then you compute the gradients, and then you update the parameters based on the equation which I showed you, that m new is equal to m old minus see, this is self dot my learning rate, so essentially this is alpha, and dm is nothing but calculating the change in gradients, and then here we are just making a simple prediction, and rest all code is just for plotting purposes and helping you visualize. So guys, why I'm doing this? I want you to understand that whenever something at a mathematical layer starts with, okay, so linear regression is the first part of it. So I just showed you, right, that what essentially happens in linear regression. We need to compute two things, m and c, and we have a loss function. Okay, we have a loss function, so we need to just implement gradient descent via coding. And basically gradient descent is used to find optimal values of m and c in terms of many iterations. So you just do iterations, and over time you would find that usually with more iterations loss increases. It's not always the case, but just for consideration. So guys, the main objective of this video is to make you and give you an understand that there might be a situation in some interviews, right? Most of you would never face it, but since I have to cover some more cases as well, so I want you to start thinking that okay, linear regression is the most fundamental thing. How do I implement that in scratch? So essentially all this code is just for plotting. The main code is only this part, the fit one. You just need to understand that okay, I need to start by making predictions, then I need to compute the loss, then I need to compute the gradients, and then I need to update the parameters, and I strictly do it on the basis of my gradient descent algorithm. So guys, this is where we have to be little careful on algorithmic approach. As I said, a lot of companies, 99.9 companies won't ask you, but guys, if you have plans on doing some stuff in depth, if you have time, so please start picking up challenges like this. They'll be fun, and obviously they'll require mathematical as well as coding aptitude. So it's okay if you don't want to do it, you want to be slightly more inclined towards business side of the story, that's also fine. That's your personal choice, but I wanted to give you a glimpse. And the main glimpse was essentially, I'll just wrap up the lecture by giving you the final story. The final story is that what we essentially did is we had a simple equation y is equal to mx plus c, and we have a simple algorithm that is known as gradient descent, which helps us compute m and c. Now the task is that how does this work? This works is that m new, that means this is a formula that is given to you, m old minus this loss with respect to m old. So we have a loss function. With loss function I use msc. What is MSC? MSC is 1 by n summation y minus y hat whole square. And I showed you how can we take partial derivative with respect to m, and then essentially we need to do all the calculations, because m old is something you will initialize, and in every iteration it will change, and this would m new will automatically update. So I wanted to give you a glimpse of how to convert maths into code. So essentially that's a very important skill which 1% of the organizations demand. But I believe you need to spend some time and figure out if you have time. If you don't have time, skip it and move ahead in the playlist. So thank you guys. Have a great day ahead, and please subscribe to my YouTube channel.